Powers and exponents. Now, if you bring things to class like highlighters, I like to, in my notes, take out a highlighter and highlight definitions. So I would highlight power and then be like, okay, what is a power? A power is made up of a base and an exponent, and it's a shorter way to write repeated multiplication. So we're going to learn that this would be a power. It has a base of 5 and an exponent of 3. And it means repeated multiplication. The 5 is going to multiply against itself 3 times. And you get 5 times 5 times 5. So 5 to the exponent 3 is equal to 125. And what we're going to want to do is find out, how do we do it on our calculator? So if I pull out my calculator, I'm going to type 5, and on my calculator, I've got a little hat button. So this little hat button moves it up to the exponent, and I can do 5 to the 3. Some calculators have the hat button. Some calculators have a button that looks, right? So on my calculator, I type 5, then I type the hat button, then I type the 3. Some calculators have a button that looks like, sometimes it's like that, sometimes it's X to the Y. It has this little tiny exponent thing there. That lets you type it in. You need to, once you get your own calculator, find out how it works on your own calculator. He has a booklet as soon as Baden realizes he has 2 and passes 1. Oh, there we go. Did everybody at the back get a booklet in the other room? Okay, good. All right. So the power is the whole thing. The base is the number that gets multiplied by itself. In our example, that base was a 5. And the exponent is the little number. And that's the number of times the base is multiplied by itself. So if I have the power, which is 4 squared, that's a base of 4 and an exponent of 2. It is equal to 4 times 4. We take the base and we multiply by itself as many times as the exponent. And what is 4 times 4? What's 4 times 4? 16. So 4 squared is 16. So we call this idea of writing something as a power, its exponential form, because it has an exponent. And it's a short way to rewrite multiplication. Grab a new notes package there. So if you had 3 times 3 times 3 times 3, we could write this as 3 with a little 4 up at the top. Because the base, the thing that's getting repeated.
27.
And then we could actually figure it out. It is 81 if we type it into our calculator. 3 por 3 por 3 is 27. Por 3 is 21. This one, it's the 10 that's repeated multiplied time. How many times has it been repeated? 3 times. So that's 10 cubed.
30.
Cuidado. 10 por 10 por 10. And here, negative 2 times negative 2 times negative 2 times negative 2 times negative 2, that's 5 times. We could write this as negative 2 to the 5, which, with a lot of repeated multiplication, that's a lot quicker to the right than the expanded form. Here we have a 2/5 3 times. So we could write 2/5 to the exponent of 3. And here we have a 0.1 to an exponent of 3. So a power shows repeated multiplication. And you can even do it with letters or variables. If we wanted to change these to exponential form, and those big dots are multiplication. Let's do the numbers first. How many 5s are there? 2. So we could write the 5s as 5s with a little 2. How many A's are multiplied together? You see there's 4 of them? So we could write a little 4 with the A's. How many B's are multiplied together? 3. So this would be exponential form. And when you have a lot of exponents, it's kind of cleaned up. Do you see how it sort of cleans up things a little bit? Like before, it was like super long showing all the multiplication. It kind of groups things together and makes it a little bit easier to understand and work with. Some people would probably do the 5 times 5 and write 25. That makes sense too. Okay? How many 2's do I have? 4. So I have an exponent of 4. How many x's are multiplied together? 3. And y's? Just 2. That would be exponential form. But sometimes when we're actually figuring things out, it's nice to have the expanded form to sort of get us thinking, what could this be equal to? 4 to the exponent 5. Expanded form, that means 4 times 4 times 4 times 4 times 4. Which if you type that into your calculator is going to be a pretty big number. Someone type it in, I have a guess. I'm going to guess 1,024. Do you check it? Is 4 times 4 times 4 times 4 times 4? 1,024?
Yeah.
Oh, nice.
Nailed it.
Got it. Okay, this one. This in expanded form would be 1/4 times 1/4 times 1/4 times 1/4. That would be the expanded form.
Answer. El 4 por 5 es igual a 1024.
See. And the last one has a bunch of numbers. So if we write this in expanded form, there's still only going to be 1/16. The 3 is just to the x. So we go times x times x times x. And I'm using the dot for times now because there's x's in this question. We start to use x's less for times when we get into algebra because we start using x's for variables. So I'm going to use a dot for times here. Is everybody okay with that? And then I have y to the 4, so that'd be 1, 2, 3, 4. That would be expanded form. All right. You want to try one on your own? Write this in expanded form. Okay, I'm joking. That would be really mean to write in expanded form.
I now see.
I was trying to keep a straight face there for the longest time. That would be, you'd have to write 252 3s in a row. That wouldn't be very nice. Okay, you don't know. Don't write that one in expanded form. The exponential form is way better. In fact, 3 times 3 times 3 times 3 times 3, 252 times. It's probably so big, I think the calculator might even crash. I'm curious. I'm going to go to my calculator if I do 3 to the exponent 252 times. It's so big, my calculator crashed. It says that overflow, it's too big for the calculator. Did you know that your calculator can't do some things? Sometimes the numbers are too big. Okay. Evaluate. So what I want us to pay attention to. One of the biggest problems people have in math has nothing to do with math. Instead, has to do with the inability to know what a word means. So this one says evaluate. If you knew that this means get a number for the answer. What is the answer? A single number for the answer. Then this becomes easier. So what I want you to do is first write this out in expanded. And you can use the dot for multiplication if you'd like, or you can use little x. 3 squared means 3 times 3.
9.
And that is equal to 9. And you can circle that, because that's the final answer. Get a number for the answer. That's what it means to evaluate. Some of these we're going to use our calculators for. Others we can do with mental math. So I'm going to get you to do some of these with mental math, and some of these you're going to do with a calculator. The second one. This will be 4 times 4 times 4.
24.
No.
24. 64.
There we go. 4 times 4 is 16. And then this is a little bit harder. 16 times 4. 64. That might be one I'd let you use a calculator on a quiz or a test. 2 to the 4 would be 2 times 2 times 2 times 2.
16.
16. Circle. I'm going to put a circle around all of my final answers. Ooh. The next one's a bit of a challenge. Let's see if you guys are ready for it. 1 to the 5 would be 1 times
5.
1 times 1 times 1 times 1, which is
5.
1. People are tempted to add that one together and get 5. But 1 times 1 is 1. Times 1 again is 1. Times 1 again is 1. I could give you 1 to the million. Put an exponent of a million. And it would still be 1. 3 cubed. Oh, they have special words when it's a 2. Have you ever heard 3 squared as a special word? For the 3, we sometimes say cubed, 3 cubed. But all other numbers, we would just say 2 to the exponent 4. Or 2 to the 4, you sometimes hear. Sometimes people even say 2 to the power of 4. These are all different ways of saying the same thing. Some math teachers don't like it when you say to the power of 4, because they're like, it's an exponent, not a power. Right? But a bunch of those are fine. Okay? So 3 cubed, or 3 to the exponent of 3, would be 3 times
27.
3 times 3, 27. And 5 times 5, 5 squared, 25. Oh, I forgot to circle that one. I want you to look at the answers we've already circled to cheat to figure out what this one is. And I just put it in, when you have brackets
27
beside,
sobre 24.
they're close. How can we use the other answers to cheat?
No.
How do you multiply fractions?
27 sobre 24.
No, sobre 24.
64.
There we go.
I'm gonna let all people know.
27 over 64. Because you already figured out that 3 times 3 times 3 was 27. And you already figured out 4 times 4 times 4 is 64. Circle that one. What is the difference? This is kind of neat. Look at these things. This one was 3 over 4 in brackets cubed. So then the exponent is to the whole fraction. Do you see in H that the exponent hits only the 3? So when I rewrite H, the top is 3 times 3 times 3. That's what that exponent is, just to the 3. The bottom stays just a single 4. Because the bottom doesn't have an exponent. And of course we already figured out that was 27, so this one's answer is 27 over 4. Usually if you have a decimal, you're going to have to go to your calculator to figure this out. But does anybody know how I could write this in fractions? By the way, let's try it on our calculator.
75.
I'm going to go to my calculator. I'm going to type in 0, put brackets, 0.25 to the exponent of 3, 0.15625. I am guessing that nobody did that with mental math. What was it, 0.015625? Or was it, did I copy it down right, or did I add an extra 0? Nope, I did it good. Does anybody know how to write 0.25 as a fraction? What is it? It's 1 on something.
1 over 5.
Close. 1 over 4.
Oh.
Does anybody know a special word for 1 over 4 when? A quarter. And what other thing do we use the word quarter for?
Coin.
Coins. How much is a quarter worth? 25 cents. Look at that. What? It's all connected. So this could be 1 over 4 times 1 over 4 times 1 over 4, which multiply the, how about you multiply the tops, I'll multiply the bottoms. What do you get when you multiply the tops? 1. Well, you guys are amazing. And 4 times 4 times 4? 64. This is the same as that. But the decimal, we for sure would need our calculator. Without the decimal, we might be able to do that without our calculator. Nice. Exponents are part of BEDMAS. Right? Brackets. Exponents is super powerful. It comes before multiplying and dividing in BEDMAS. So now the question is, are these two the same or are they different? Will they get the same answer or will they get a different answer? Well, one, we could go to our calculators because our calculators are really good at BEDMAS and check. So I'll type these in and then we're going to have to explain why. The first one was negative 3 squared. And the answer, guesses? Any guesses what the answer is before I push enter? Okay, we need someone to randomly guess. Stacy, pick somebody to randomly guess. That way nobody gets mad at me, they'll just get mad at Stacy. So pick someone. Yeah. Who's going to guess?
Abel?
Oh, what are you going to guess? You can guess anything. I don't care if you're right or wrong. What do you think it's going to be? Negative 3 squared. No, don't say anything. No. You just get a guess. You can pick 5. By the way, 5 is wrong, but you could guess that. Negative 6. Okay, here it is. We're going to push enter. Negative 9. Okay, so this one on our calculator says negative 9. What do you think the other one's going to equal? Guess what, Abel? You get to pick the next volunteer. I'm going to put negative 3 in brackets this time, and then
Nueve.
square. Who are you going to pick?
9.
All right, it's better. Dayton, you get a guess.
What did I guess?
You guess what? I'm going to push enter, and it's going to give me an answer. And we're going to see if you can guess right or wrong. Doesn't matter if you're wrong, though. What do you think negative 3 in brackets squared is going to be as an answer? Negative 6. Push enter. It's positive 9. All right. So, the question is why? And if we know that an exponent means repeated multiplication, we can figure out why the first one's negative 9, the second one's 9, and why none of them are 6s. So, this is how it works. If I have the first one, which is negative 3 squared, the exponent hits what? Just the 3. So I would have a negative, and then the exponent hits the 3. This means 3 times 3. I'll put that in brackets, because that's what the exponent part is. At break time.
9. Negative 9.
Because you're supposed to go like either at lunch or at break time. If it's an emergency and you can be back in a minute, yes. All right. You have your phone in your pocket? Then you have to leave it here. Okay, awesome. Okay. And then 3 times 3 is 9. 9 with a negative out in front, that's a negative. The second one, when I have negative 3 squared, now the exponent hits the whole brackets. So this is negative 3 times another negative 3. And a negative times a negative
9.
is positive, and 3 times 3 is 9. I want you to try all of these on your own. Some of them are going to be 1. Some of them are going to be minus 1. You have to decide based on the exponent and what the exponent hits. And I'll give you the answers in a bit. I'll split them up. Here you go, Ken. This one, and this one, and this one. There we go. 1, 2, 3, 4, 5, 6 of them. Ooh, I'm going to add one more. I'm feeling like I want to add one more. There, that's the one I wanted.
Mr. J.R. Está súper difícil.
Right. Ready to see if you got them right? The first one is
Wow.
minus 1. Why? Well, first of all, the 3 just hits the 1. So you would do 1 times 1 times 1 first, which is still 1. And then you multiply by the negative in front, keeps it negative. So in this one, I'm going to put a circle around this. That's the only thing the exponent hits. And that's going to be equal to 1, and then you have a negative in front. The next one is positive 1. Oh. Because it means now the exponent hits the whole thing, so it means negative 1 times negative 1, and a negative times a negative makes a positive. The third one. is a negative
One.
1.
How?
Because the 3 hits the whole thing, means a negative times a negative, which makes a positive, times another negative, makes it negative again. If you have an odd number of negatives, it's negative. If you have an even number of negatives, it's positive. This one is very similar to the first one. That 203 just hits the 1. So that green circle is equal to 1, and there's still a negative out in front. This one is negative 1.
Hansel, una pregunta.
Ujú.
¿Y por qué el que tiene en barra no es en positivo en vez de negativo como el otro?
¿Con este?
No, es
Este. Porque negative 1 to the 3, negative 1 por negative 1 por negative 1. 3 veces. Negativo por negativo es positivo. Por negativo otra vez es negativo.
Entonces, si es 2 veces es positivo, y
Sí.
si es 3 es
Sí.
negativo, y si es 4
Cuatro.
positivo.
Exactamente.
Ok, ya entendí.
Entonces este.
Positivo.
This one is positive 1. Because you would have the negative 20 times. And if you have an even number, it becomes positive. What about this one?
Negativo.
That'll be negative 1. Because it's an odd number of times. And the last one
-1.
is negative 1. Even though it's an even number, now that 10 just hits the 1. And that's equal to 1. And then you do the negative last, because order of operations says you multiply at the very end. So, something that we see here, some notes that we see with these negative 1s. If you have a power with a negative base, if it's without the brackets, right? If you have this, negative 2 to the 4, without brackets, it'll always be a negative answer. Because you would do the exponent first, 2 to the 4 is 16, and then times by the negative. With brackets and an even exponent, so if I had the brackets here and I had the 4, then it's going to be positive. Because you'd have that negative 2 4 times, and 4 negatives make it positive. And if you have brackets and a negative and an even odd exponent, sorry, it will be negative because you would have 3 negatives. Negative 2 times negative 2 times negative 2. And that would equal negative 8. So I would like you to try the next 6 on your own. You can use a calculator if the multiplication is too big for you. And I'll put the answers up in a bit. Did you get negative 16?
Yeah.
Did you get negative 7?
Yeah. Wait. 6.
Did you get
Uno.
positive 1?
Yeah.
Yeah.
Did you get a negative 125?
Yep.
Okay.
Did you get positive
No.
16?
Yes.
And did you get positive
10,000.
10,000?
Yes.
Um,
I didn't even have to do that.
Okay, now there are last ones to do on your own. You can use a calculator. You can grab one if you need one. I'll put the answers up in a second. Done all the calculator stuff? Or need a little bit more time? A little bit more time? Okay. On your calculator, did you get
512.
512?
Yep. Wait, I got 512.0.
Oh, then your calculator's got some weird .00 thing happening.
I think she just did it wrong.
Let's see. 2, exponent button 9.
Wait, how is it doing that now?
Oh! Did you use the exponent button?
The Jets tonight,
Oh, I
right?
think I did. But,
I
Mom.
don't know.
Jets play tonight.
I feel like they should. They haven't played for a while.
What's that?
3 to the 5. Did you get what?
2400.
243?
Yeah.
2,000? No.
Minus 100,
I did it.
1,020.
And this one.
15,625.
Like this, shut up.
This one is a big one for me. Is it
This one.
15625?
25.
Oh, that one hurt my mental math brain a little bit.
Stupid, you don't know what a conservative is.
Oh, and this one. This one.
Negativo 1000.
Negative.
Negative.
1296.
29.
11296.
Yes, that's better.
Negativo 126.
Negative 1,296.
I got it right.
Awesome. Okay.